So here's a summary of 1.13. So control structures are any of these: if else, while, or for. Any of the things that make it so when we're performing our code, we don't just go in a top-down order. We go to the control structure, do what it says, maybe we loop, we then leave it, and then continue in a top-down order. Why do we use it? To control the flow, to make it instead of linear, to make it a little bit less linear, and to execute based on certain conditions. What's a condition? Well, we know the Boolean condition, something that's true or false. We can have code execute, as we'll see later in Java, in other conditions besides that, when a certain number is true, and so on and so forth. So let's take a look at some of the example code they give us in this section. Most of it is just example code. So we have a while loop with an if loop inside of it. Yes, we can use a control structure inside a control structure. Then afterwards, we do another one. If we recall from the if unit, this is kind of like a safe take ball method. Only if there's a ball present will we take it. So just for fun, we're going to refactor our code first. I'm going to call this safe take. Refactoring is when we take our code and rearrange it to make it a little bit more legible. So if ball's present, take ball. We have that here and here. We're just going to erase it, write that code in, is this indented properly? No, this needs to be one less. So we've just replaced this and this. We're missing a semicolon. So this is the example world, so it's not going to tell us we got it, but if we run it, we'll see. We just jump down to check here. And basically all this does is it cleans up the whole thing while the front's clear. Once we get to the end, it has to then check one more time just to make sure everything's clear, and it's good to go. Here we have the random hurdles, and I wrote some pseudocode in during class to kind of make this a little bit more understandable. So why don't we take one more look at the problem, and I'll code the example. So we have to jump all of the hurdles. They could be in random locations. So if you recall the exercise from a few aims ago, we didn't have it random. It was always placed in a certain order, so we would always just move, jump the hurdle, move, jump the hurdle. Now it's random. So we kind of have our pseudocode here. We want to move forward, and if we can't because there's a hurdle, we have to jump over the hurdle. So why don't we take a look at this code. So once we've finished writing our jump hurdle command, it's time to test it and then actually finish writing the program. So we're right at a hurdle already, so we could just type jump hurdle, see if it works. We want Karel to be at the start, or at the other side of the hurdle, facing right once we're done. Does this work? Good. If not, we could always add commands, reset, run it again. So what do we need to do? We need to go all the way across here, and if there's a hurdle, we jump it. If not, we move. So that sounds like an if-else, doesn't it? Let's write our if, bracket. Well, it's closing with my run bracket. That's no good. Bracket, our jump hurdle, and we could close it. And then the else block. No condition for the else. If what? If, well, we're going to jump it if there's a hurdle, so if the front's block. If I typed that wrong, don't forget we could always go over to docs if we're not sure which one it is, but it looks like I got it. Front is blocked, jump the hurdle. Otherwise, we move. And we could switch this and make this if front is clear, move, else jump hurdle. But we're going to leave it like this. Just know that either one of those would work. Okay, so what happens? It's only going to do it once, right? You're going to keep moving. So we can just loop this, as you probably would have guessed. Why are we in a loop? Well, it's here. We could try using some kind of while condition and figuring out a weird way to make it so Karel checks here, but we're kind of limited, so let's just use what we have. If we look at all of our worlds, we know that they're all the same length, so as long as our for loop works on one, it'll work on them all. Okay, so for condition brackets. We want all that in a for loop, right? Now my indentation is off, so here's everything in between those for loop brackets, tabbed over, good to go. We don't know how long it is. Let's try and guess. Does it work? This is much too slow. Not far enough. Okay. Column 14 is on column 11. We guess 10. So what's 1 less than 14? 13. If we run it from here, it will reset it. So that's good. Looks like it works. Works. Let's try submitting. Looks good. .14 has just a few other examples for us to take a look at. So let's do so. I'll let you know some of these methods might be useful in the Karel challenges later. So here we have just a simple move. We move on to the ball. While the ball is present, we then move one ball, and that's another method that they wrote. We take the ball, we move forward, we put the ball there, we turn around, which is a Karel command. We move back to the balls and turn around, ready to do it again. So what this looks like we'll do, it should take a ball and move it over. It's not actually having a dog pick up and move a ball, but it's very similar to it if you really think about it. So let's just run it, step through it slowly, see if that makes sense. Move one, take, move, put, turn around, move. Okay. He kind of jumps from the balls back to the balls, kind of sort of imagining him placing it on the next step. Nothing too complicated there. And the climbing one. Well, this one's a little bit more involved, so let's see. We have a loop that runs 7 times, and we have 1, 2, 3, 4, 5, 6, 7, 8 rows. And that seems to work. Let's see what happens. We have to move up 7 times if we have 8 rows and we start on 1, right? So what does this move up? Well, while the left is blocked, so a lot of us like to use front is blocked, but left is blocked would be Karel's top, the direction he's facing if he turns left. And if it's blocked, he moves. Once it's not, he'll turn left, move, turn left, move to the wall, another command, just checks to see while the front's clear and moves it, and turns around. So without actually running this, we might not understand what's going on here. So why don't we do that and step through it nice and slow. Okay, we're going to move while the left is blocked. Then we'll find this opening. Once we do, we turn left, we move up it, we turn left again because we kind of want to get to the back to the left side because that's how our code kind of works. Turn around, we're ready to try it again. Move until the left is blocked or is not blocked. We turn left. We get to the start of the next row, turn around, do it all again. And notice that move up calls move to wall is down here. We can kind of see Karel climbing. So just keep this in mind if we have to maybe write a program where we're going up and down each row one by one. And finally, here's the Super Mario Karel 2. This is a lot similar to one of the other programs, Mario Karel, that we did way back at the start. So this time I want us to jump and collect the coins. You have to use a conditional to see if there are coins, and you should of course break it up into methods. We can't just run around the blocks, and it has to kind of work for any size world, and there's a few here. So hopefully that helps you out.